Okay, this is section 8.3, exercise number 8, in which you are asked to use the integral test to determine the convergence of the given series. So just to be clear, we're only trying to determine convergence or divergence here. We're not actually going to be using these tests to necessarily find the value of the series if it does converge, but rather simply that it does converge or does not converge, namely diverge. They specifically ask us to use the integral test here, and so what we want to do for this particular series is to consider the integral from 2 to infinity of 1 over x ln x. Right, the integral test tells us that this improper integral should have the same behavior as our sum, our series that we're trying to study. So recall our improper integrals are limits. So the limit is b goes to infinity of the integral from 2 to b. And so we need to compute this integral and then study the limit as the value b goes to infinity. This is an integral we can tackle with a substitution. So if we let u equal the natural log of x, and du will be 1 over x dx. So the underlined integral becomes simply the integral of 1 over u du, which is the natural log of u plus c. But we're going to be doing this from 2 to b, an indefinite integral. So I'll leave out the plus c. So we'll come back now and plug in for u. So integral from 2 to b for x and x. The natural log of the natural log of x from 2 to b. And we're putting u in for, technically this should be absolute values here, which is the natural log of the natural log of b minus the natural log of the natural log of 2. So that's our underlined integral up here, and now we're going to study this integral as b goes to infinity. So we want the limit as b goes to infinity of the natural log of the natural log of b minus the natural log of the natural log of 2. The natural log is an unbounded function, and so this part in here is headed off to infinity. So this entire term, the natural log of that value, is also headed off to infinity. In other words, this limit, we might say it equals infinity, but more specifically, this limit does not exist. And so by the integral test, the fact that this limit does not exist, or that we could say that it diverges, by the integral test, our series also diverges.